discussing a survey that I did of open source PDF solutions. And I'm going to be focusing on those solutions that provide the capability to render PDF content to images or raster content. And I'm going to be looking at those things in regards to three different aspects. One is, are they rendering the pages correctly? What is the timing performance of these things? In other words, how long is it taking to render the content? And then finally, how much memory is being used by the code? And let me make sure there we go. Okay, so before we get too deep into that, though, it's worthwhile to kind of go over the different types of open source licenses out there. And I want to do this with the caveat that, I'm not a lawyer, and if you have any questions or concerns about if you're following certain guidelines that are required to use certain open source licenses, then best to consult an attorney. It's worthwhile to talk about the different flavors of the GPL license. There's the LGPL, just the GPL and the AGPL. So the LGPL is the lesser general public license, which allows for commercial use of the code. If you do any changes in the code, though, you have to provide those. But you're allowed to basically, use LGPL code with your commercial code, and there's no problems with that. With the GPL license, if you try to incorporate GPL code into your proprietary code and you're going to ship that off, then that requires that your proprietary code now would need to be GPL licensed also. And so in that sense, the GPL license is sometimes referred to as being viral or infectious license. And then finally, there's the AGPL, the Vrhel GPL license, which addresses a loophole that existed in the GPL license, whereby it was possible for people to make use of GPL code and run it on a server and basically provide a service in that way, and basically use it in a way that wasn't really the original intended spirit of the GPL license. And so the AGPL closes that loophole. And we'll talk. There's several projects that we'll talk about that have both the GPL and AGPL licensing. And within those projects, there's also often other projects that are used that have other open source licenses. For example, some projects make use of certain libraries like Little CMS, for example, which has an MIT license. And here we have a list of other open source licenses, including the Apache license, which is a very permissive license. All it requires is a list of modifications if you do any, but it's basically you can use it with your proprietary code without any problem. MIT license is also extremely permissive, just need to include the original license and copyright information. The BSD license is similar to Apache license, but from my understanding, there's some issues perhaps with or question marks on patents, and I don't know a lot about that, but that's just basically what I've read. And then the Mozilla public license, of course, is another very permissive license. So that's the different types of licenses that you typically run into out there. And so if we talk about open source PDF solutions that are capable of doing rendering, and generally these applications also do more, we have the following list where we have Goscript, which uses the AGPL license. There's Xpdf, which uses a GPL license. There's the Apache PDFBox, which uses as you might guess, an Apache license. MovePDF, which has an AGPL license. There's Poplar, which has a GPL license. And then there's pdf.js and pdfem, which both have an Apache license. And as I said, these are the projects that I'm aware of that have rendering capability. There's also several other projects out there that deal with PDF, but mainly on the side of doing PDF creation or manipulation. And I just want to mention those because I don't want to leave anybody out. For example, iText has an open source solution that's written in Java and .NET to do PDF generation and manipulation, and that has an AGPL license. Open PDF, which is a fork, from my understanding, was a fork off of the Java iText project some time ago, and that has an LGPL and a Mozilla public license. I guess you get your choice of which license you want to use. QPDF allows some limited PDF manipulation, and it's written in C++, has an Apache license. There's a C++ library called Podofo, which allows you to parse and modify PDF content and create new ones, and it has an LGPL license. And then there's a project out there that is it's basically a PHP class for generating PDF documents, and it has an LGPL license. Again, I'm not gonna go into any details on these. Comparing these projects would be difficult in the way that I'm trying to compare the other ones, which is are they doing the rendering correctly, and how long is it taking, and what's the memory usage. It's worthwhile or interesting, I guess, to look at the timeline of the open source rendering projects and the PDF specification, and hopefully you can see this. I don't never know, depends on your screen resolution, I guess, but over here on the left we have PDF was first introduced in 1993, and at that time, work began on bringing PDF capability into Goscript, and then basically in January of '95, Goscript released PDF support, and then later in the year, Xpdf did its first release, and then we have the release of PDF 1.3, 1.4, and then around in 2002, development started on MooPDF, and development started on the PDFBox code. And then by 2005, the first release of MooPDF occurred with its current graphics library, and at that time there was also the fork of Poplar, which was made off of Xpdf, and then we have PDF 1.7 and the ISO specification of PDF, and then in 2010, PDFBox was first released, 1.0 was released. In 2011, pdf.js was released, and in 2012, MooPDF 1.0 was released. And then in 2014, PDFEM was released as open source, and then I'm going to fast forward all the way to 2020 and 2021. Where here I kind of have crammed in here all the most recent releases of everything. PDFEM is not in here because it's kind of on a continuous release model, which has its advantages and disadvantages. But so what I'm going to do now is go through each of these projects a bit more in detail, basically in the order that they introduced PDF capability on that timeline. So we'll start off with Goscript. Goscript's written in C. Goscript initially was released in 1986 as a PostScript interpreter and rendering engine. And as I mentioned, the work on the PDF interpreter began in 1993, and then was actually released in January of 1995. Current version of Goscript is at 9.55, which was just released last month. The web address is at goscript.com. It has an AGPL license, but it also has a commercial license from Artifex software. So it's one of these projects that has a dual license, and there's a few of those out there. The code supports overprint capability, which is if you're not familiar with that, that is a feature in PDF that allows you to overlay certain colorants on top of other colorants in a manner that won't erase the existing colors. You can do drawing commands that, for example, to place just cyan on top of whatever other colorants happen to already be laid down. You can render pretty much to any color space as output, gray, RGB, CMYK, device N, with and without alpha channel. It does not handle any interactive features. You can turn off and on anti-aliasing control. One of the interesting features of it does allow you to do high-level conversions between other page description languages such as XPS and PostScript and PCL. And it has an API that's written in C, and there's bindings, language bindings provided for Python, Java, and also C#. Xpdf was the next on the list. Again, it was released in 1995. It is written in C++. Here's the web address is at xpdfreader.com/download.html. It's, again, one of these dual license models where you can either use the GPL version or you can actually get a commercial version from the company that owns the copyright, which is called Glyph and Cog. The code renders to RGB and gray. I couldn't find any capability to do CMYK. The last release was in January with version 4.03. It does not do overprint or interactive features. You can turn off and on anti-aliasing control. And there's, from what I can find, there are third-party Python bindings out there that you can use with the code. Apache PDFBox is a little bit unique in that it's written in Java. Its development started in 2002. First release was release of 1.0 was in February of 2010. Most recent version is from June of this year, was 2.0.24. Although if you go to the website, I see they have an alpha version 3 that is available. It uses the Apache license. The web address is pdfbox.apache.org. It renders to gray, RGB, and alpha RGB. I couldn't find any capability to do CMYK. Does not support overprint. I couldn't figure out how to turn off anti-aliasing, and does have the capability to export and import acroform data though. MooPDF is written in C. Work started on this in 2002, and then version 1.0 came out 10 years later in 2012. Current version is at 1.19, which was just this past month. The web address is at moopdf.com. It's another dual license code base with AGPL or a commercial license from Artifex software. Supports overprint, interactive features, and acroforms, renders basically to all the color spaces. You can turn off and on anti-aliasing. They provide an API in C, Python, Java, C++, WASM, plus there's app kits for iOS and Android. And it also includes a JavaScript open source interpreter that lets you do scripting basically to interface to the code base. Poplar is interesting in that it was a fork off of the Xpdf code back in 2005. So from Xpdf version 3.0, similar to the Xpdf code, obviously then it's written in C++. The most recent release is back in this past month. The code and information is available at poplar.freedesktop.org. It uses a GPL licensing and renders a gray RGB and does do CMYK. Has the capability to convert to PostScript. I did not do any testing with that. You can turn off and on anti-aliasing control, and it supports acroforms, annotations, and overprint. And it's pretty easy to find third-party Python bindings to use this code base. pdf.js is an interesting one that's written in JavaScript, which I can't imagine doing, but that's what they've done, and it works great for people who want to do PDF viewing on web pages. Initial release was in July 2011. Here's where you can basically get the code is at this GitHub address. It uses Apache license. Most recent version was July of 2021. Basically, it renders RGB content onto a HTML5 canvas. Does not support overprint. As I said, it only outputs RGB. You can't turn off anti-aliasing, but it does support annotations and acroforms. Finally, and sorry if the font's so small, there's just a lot to put down on this one. PDFEM was the most recent addition here. It was a fork, from my understanding, this is a fork off of Foxit's PDF SDK in 2014. And it's a Google open source project, and it has an Apache license. And here's the web address for this code base. As I mentioned, they don't do, from what I can tell, they don't do formal releases. There's kind of a continual, whatever's been added to the code, that's the snapshot of where it is. It's written in C++, renders to gray, RGB, and RGB alpha. I couldn't find any capability to do CMYK. You can turn off and on anti-aliasing, does conversions to PostScript, does not support overprint, does support acroforms, XFA, and uses the JavaScript AV8 engine of Google's to do the interactive features. There's several third-party C# and Python solutions out there, and if you go on GitHub, there's projects out there that make use of this to build on iOS, Android, macOS, and WASM. And from my understanding, PSPDF uses PDFEM as their rendering engine in their products. So that was the kind of the rundown of all those different projects we'll be talking about or that I'll be testing. What I did was I went ahead and got all the code bases. I built them on Windows. The exception being that for PDFBox, I went ahead and grabbed the Java binary, and for pdf.js, I actually ended up writing a little bit of code in HTML and JavaScript to go ahead and do a conversion of PDF. If I have a PDF file, I can go ahead and select it and then basically convert all the pages to PNG, and that runs on Firefox. I used a 4-core Intel machine that had a clock speed of 3.2 gigahertz and 12 gig of RAM, but I went ahead and clocked this machine down to 1.6 gigahertz. I wanted to avoid any thermal throttle issues when I was doing the testing. And as I mentioned, I evaluate each project on its rendering accuracy, its processing time, and its memory usage. So I picked 3 different files to do this. One was basically a 4-page file here on the left, and this just shows page 1. And it's basically packs in the Ghent tests into 4 pages. And the Ghent tests, if you're not familiar with them, test various kind of corner cases of PDF with transparency and overprint and spot colors. And so those 4 pages were rendered at 600 DPI. Next file was an Altona test file, which was also kind of a stress test of different corner cases. That one consists of 17 pages. Those were rendered at 600 DPI. And then finally, I took a text document, in this case, the version 1.7 of the PDF reference manual, which is a little over 1,300 pages, and I rendered that at 150 DPI. So I did this with each of the 3 projects. And I'm just going to show some samplings of, and I apologize for the resolution. I probably should have presented this a little bit different now looking at it, but here's some examples of some rendering issues. Here on the, this is from on the left here, we have the PDFBox looking at the Ghent file. You can see up at the upper right here where there's X's in these little squares. If there's X's in there, that indicates that it did not render properly. And here, basically, these little tests are doing tests of various blend modes of transparency. So it's struggling a bit with that. In the middle here, we have Poplar running the Ghent test, and this where you see this X and this image on the right-hand side. That's supposed to be a 16-bit CMYK image that's rendered there, and for some reason Poplar's struggling to get that rendered properly. And then on the right here, we have Xpdf, which in this bigger case, there's some X's on this one section of the you see some red X's in the green squares. That's where it's having some issues with doing overprint, which it did not support. Some other cases, PDFEM struggled a bit with some of the Altona files pages. This particular page on the image on the left, the image on the top is supposed to look like the one on the bottom, and you can see that this is actually quite a difficult page to get correct, since it's overlaying a whole series of transparency groups with different blend modes and soft masks, etc. But PDFEM was struggling with that. And then pdf.js, for example, on the same file, Altona file, but different page, the content on the left of that, where we have these yellow and green or blue stripes, is supposed to actually look like the stuff on the right with the circles. And that's basically testing various blend modes with shadings. So what you have to remember about this, though, is that these rendering issues is that these are rather corner cases. I mean, these are stress tests. And so with the case of the text document, for example, which is a bit more common, everybody did quite well on that. So now let's go ahead and look at timing performance. So this is on the Ghent file at 600 dpi. Here on the vertical axis, we have seconds that took to render, and basically I placed the seconds on top of the bars here. On the horizontal axis here, I have the different cases that are run, and you'll see that, for example, I've run MooPDF with 4 different cases, and the reason why is I wanted to see, with and without overprint support, and running the different color spaces of RGB and CMYK. For those applications that only did RGB, then that's what we did without overprint, for example. So we have MooPDF RGB with no overprint, then MooPDF RGB with overprint, MooPDF CMYK no overprint, MooPDF CMYK with overprint, and then Xpdf RGB no overprint, poplar RGB no overprint, poplar CMYK with overprint, PDF EM, which ran with RGB no overprint, Goscript RGB no overprint, Goscript RGB with overprint, Goscript CMYK with overprint, and then pdf.js RGB no overprint, and PDFBox RGB no overprint. So on the rest of the slides, this horizontal axis is going to stay the same, so I'm not going to read that every time. But what we see here with the timing performance is that pretty much all the native methods are running quite similar. When I say native methods, I mean those written in the not to run on a virtual machine, like pdf.js and PDFBox. The exception being here is that poplar CMYK was taking quite a bit longer on the Ghent test. If we move to the Altona test, we see very, again, similar kind of thing. The codes that are running on the virtual machines, of course, are taking much longer, as would be expected. In this case, poplar and Xpdf are probably struggling a bit more with this file than the other code bases. With the timing performance on the text-based document, so we see things change a little bit here, in that PDFEM ends up running quite fast on this document. So it takes it, to do 1,300 pages, takes it about a minute to do that at 150 dpi, which is quite fast. And I'll talk a little bit more about that in a minute. And you can see, again, the code base is running on the virtual machines, taking a long time. This is timing performance. Now let's look at memory performance. So this is now we've replaced on the vertical axis here, this is megabytes used. And you can see that the virtual machines are swamping everything here. So what I want to do is go ahead and just show the non-virtual machines here, so you can see how they're behaving. So we've removed those from the chart, and you can see that Goscript is doing probably the best on that, and everybody else is doing somewhat similar to one another. This is on the Ghent file at 600 dpi. If I look at the Altona file, again, the virtual machines are out there, so we'll zoom in to the other content. And interestingly, for some reason, Xpdf suddenly, started to excel on the Altona file. I'm not sure why. And then you have Goscript and the others. With the PDF with the text-based spec, again, zoom in, and this is where it gets interesting. Recall that PDFVM, which was getting this job done in 60 seconds, is using the most amount of memory here, and we did a little bit of looking at that, and the the a lot of these code bases end up doing basically sub-pixel rendering of characters, and then storing those characters in a cache. And in the case of PDFEM, I think we determined it was using for each character at particular resolutions. I can't remember if it was at 150 dpi, but I was using something like 3 different sub-pixel renderings, and then storing those in the cache, which was obviously a large cache. A lot of these other code bases could be, they're also using character caches, but they could probably be, reconfigured to have a larger cache, or to do less or more sub-pixel rendering if they're doing that. And so you always have this constant trade-off. If you're designing for a particular system, we're going to use one of these code bases for an embedded system. What's your trade-off of performance versus memory usage? You always have that going on. So that's pretty much what I had for that. And just to summarize, there are several options out there in terms of license types available. There's the GPL, and I use GPL loosely here, in that some of these are AGPL. So there's HEPL and GPL code bases of Goscript, BooPDF, Xpdf, and Poplar. There's Apache license code bases out there, including PDFBox, pdf.js, and PDFEM. The native language solutions had very similar performance. So that's Goscript, BooPDF, Xpdf, Poplar, and PDFEM, with some exceptions on certain files where, for example, PDFEM did quite well on the speed-wise on the text document solution, and Goscript had quite good memory performance on the Ghent tests. On the virtual machines, the code bases, PDFBox, PDFJS obviously used more memory and are slower, but they have their places. PDF.js, especially if you're working on adding PDF capability into your web application, it's a great solution. There are some rendering issues seen in the corner cases, and those mainly are in transparency and overprint, but all did well in the text document rendering quality. And that's all I had, except I do have one slide, Duff, and I wasn't sure if I jump right into that one, the commercial slide, or if we...
Go ahead and mention it. Yep.
Okay. So a little bit about Artifex software. Artifex has its roots in open source with Goscript and BooPDF. We have lots of solutions for doing PL processing and conversions between PDF, PostScript, PCL, and XPS. We have solutions for dealing with Office documents, both the older binary formats and the newer XML formats. These solutions allow you to render, view, edit, create Word document content. There's solutions for working embedded, cloud, enterprise, print, mobile. We have partners with over 150 OEM leaders, including Google, BlackBerry, and Garmin. The engineering staff is global, and which allows us to provide prompt support, and we've been profitable for over 100 consecutive quarters. Okay, that pretty much concludes everything.
Great. Thank you, Michael. That was very interesting indeed. And there are several questions that are already piling up for you. So I'm going to get right to it, if that's all right with you. I should mention
that's fine.
Great. So Michael's slides are available in the handouts pod in the GoToWebinar control panel. So the first question here Do the performance figures you mentioned include file output times, for example, the ping or TIFF? Is it a single timing measurement or an average of a time of run, of a number of runs?
Right. So it is actually, so I ran a set number of runs. I think I did 10 different runs. And then for timing wise, I took the fastest one. So that's what you're seeing there. And I had to include the file IO time with all those because some of them, there are some of the applications that allow me to actually do the timing and allow me to separate that out. But I had to be fair, and everybody has to. If I can't do it for one, then I can't do it for any. So those timings do include file IO time to write out the raster data.
That's kind of a lead into another question we had here, which is, did you measure time to first page out?
No, I did not. That would be an interesting one.
Okay. What differences would you do to make this survey relevant for screen-based rendering, such as for viewers, rather than print-centric high-resolution CMYK and so on?
Well, I mean, I would basically drop the resolution down. I think the text case with running at 150 DPI, I mean, I don't think that's unreasonable with today's screen resolutions to really be realistic. I mean, running 150 DPI RGB isn't too far out. I mean, I could have done another 72 DPI, but even some displays that might be kind of not sufficient. So I think the 150 DPI PDF document that I ran with RGB case and no overprint would be representative.
Okay. A longer question here. So an attendee writes in to say that he's looking to build a solution for rendering SVG flipbook and enriching that with annotations. And he's wondering what method he should use to determine the best combination from those tools for conversion and annotation. What method or what characteristics should he be comparing and looking out for when building that kind of complex service? Any other information you could spill on that subject would be appreciated.
Wow. Well, yeah, SVG.
No pressure.
So yeah, I didn't really look at to see who has that capability in terms of doing SVG, and so I don't want to make any comments on that because but if I was building an application like that, I'd have to look at what I'm running on it, and I'm running on an embedded system, am I running on a desktop, am I running on what's my memory usage or availability, and do I have multiple cores? Does the library allow me to leverage the use of those cores? Because it turns out that some libraries, have multi-core rendering. I didn't get into that too much, and some libraries don't, and some libraries allow you to do multiple threads, and some libraries don't.
Mm-hmm.
So it's something that you have to dig
It's
through the
pretty detailed.
documentation. Yeah, and that's where I would start.
Okay. So last question I have here right now is how difficult were all of these things to build from the source code?
Yeah, that's an interesting one because it varied quite a bit. I I guess for me, Goscript and MooPDF were very easy, but that's because I'm very familiar with those code bases. So, you can't ask me about those. Someone else
No,
would
we're
have
not.
to look at that. But the other code bases, PDFEM uses a very strange build tool system. Strange to me, and I think it's a little bit unique to Google. If you're a Google employee, it's probably quite simple and straightforward, but it the instructions were there, and if you follow them exactly, you can get it to build, and then it works. But if you make any kind of accidental mistake along the way, you find yourself in all kinds of trouble. Uh, the one that took a long time though for me to build on Windows anyways was Poplar, and I think just part of it was because I was building on Windows. If you know, I had been focused more on Linux, I probably would have been better off on that particular project. But I couldn't build one on Linux though and one on Windows. I had to make sure I was going on a common platform for everybody to make sure the testing tools were being fair. And the rest of them were pretty much not too bad. But PDFEM, again, the instruction sets were there, but it was difficult to get all the tool chains set up. But once you did have it, there was a set process.
So I think the last question we have time for here is, did you measure file size, that is to say space on disk, for each solution you checked out?
Yes, I should have done that, and I apologize. That would have been a good one.
Next
Footprint. Yes, next year.
year.
I'm gonna write myself a note. I did think about that at one point, but then I got sidetracked. So no, I can't make a comment on that. So that would be go ahead.
Sure.